So we have covered the theory in the previous video. In this video, we're gonna see how to perform the test and what data we have to collect. Let us introduce ourselves with the cam kit setup that we're gonna use. It is the ES12, and you will have 4 different types of cams and followers in this module. So let's see how to perform the peer cam and how can we generate the displacement profile for peer cam. What you're seeing on the left is the theory that we have covered, and here you can see a pointer where you can use to count the angle, and this is the cam, peer cam, and this is the angle reader, and this is the roller follower which will make the rod go up and down, and from the reading when you move the cam, and you will get this red bar starting from 0, the displacement at different angles. So what you have to do is to create a similar displacement profile that should look like this at different angles. So at maybe at 0, 20, 30, 35, 40, 60 different angles, you have to measure how much is the displacement and record the data. And you should be able to, when you plot them, you should be able to get a similar displacement profile for peer cam. And now in next slide, we're going to see what are the data we have to collect. So the data collection for all the 4 cam setup, as we explained in the previous video, you have to collect the data of displacement at different angles. So for all those 4 cams, you have to rotate and stop at different angles. For example, 0, 20, 40, 60, up to 360 degrees. That means a full rotation. You have to stop at those angles and measure how much the red bar on the scale goes up and down. The position will give you the displacement. And once you have those data, you can plot those displacement against those angles and you'll get your displacement profile. So now let's look at how the offset circular cam, if we do test with that, how the profile will look like. Again, if you use offset circular, your profile, displacement profile, should look something like this. Again, what you have to do is that at different angle, you can use the pointer here to count what angle you are at right now. You can stop at different angle and take the measurement, what is the position of the red bar at that angle. And that's how you collect the data of the position displacement at different angle. Once you plot those angles with the displacement, you should get similar profile like this. Now let's look at the test procedure for hard cam mechanism. Again, on the left you can see the theory that we have learned, how the displacement profile should look like a triangular. And again, on the right you can see the hard cam. You have to pause at different angle and measure how much is the distance from 0, those positions, and you have to record those at different angles. And again, from 0 to 360 degree, a full rotation from 0 to 360 degree full rotation. Once you have those displacement, you can plot them and you should get a displacement profile similar to this displacement profile that we learned in the theory. Now we're gonna see the drop cam mechanism, the final one. So you might have seen that the drop cam can rotate only in one direction, and right there it has an edge. That's why it cannot go opposite direction. So the drop cam, the limitation is it can rotate only in one direction, and you'll be able to see this drop cam cannot go opposite direction. Like this counterclockwise, it can always go clockwise, it cannot go counterclockwise. So it cannot go counterclockwise, it can just go clockwise. So that was the four different tests we're going to do with the cams. Now we're going to see what and how to produce our results. So in the results section, you have to present the experimental data that you have collected for all the different mechanisms, all four different mechanisms tested. And you have to plot the displacement versus cam angle from 0 to 360 degree and plot those displacement that you have collected from the red bar movement. And you should get the displacement profile. So you have to plot four displacement profile and discuss the characteristics of those each plots. So in comparison, during the discussion section, compare the displacement profile. One is look triangular, one is bell shaped, and why they are those displacement profile is somehow connected to the shape of the cam. Discuss all scenarios and explain the reason for the different response. The displacement profile, like I said, why they are obtaining different cam are different, and are they connected with the shape of the cam. So discuss that in the discussion section. Finally, we come to our conclusion part, where you're going to write a brief paragraph summarizing the experiment that you have performed, all four tests, the main result, the comparison. Maybe you can present in the table, and any inference that you have drawn from any decision you're going to propose from the test. And these are the references. This is our textbook and the Tech Equipment ES12 handout that we have used. So that concludes our lab with cam, four different types of cams and followers. I'll see you in a different class and different video.